Welcome back to day 49 of the Edulexis Complete Python course. Today, we are unlocking one of the most powerful tools in programming, regular expressions, or simply a regex. Have you ever wondered how websites check instantly if your email format is valid or if your password contains a special character? They use regex. In this video, we will learn how to write simple patterns to clean, filter, and validate data easily. No complex jargon, just practical beginner steps. Let's get started. To work with regular expressions in Python, we do not need to install any external libraries. Python comes with a built-in module called re, which stands for regular expressions. To bring its power into our script, we write import re. This single line gives us access to a complete set of functions designed to search, match, and validate text patterns effortlessly. Let's make sure your editor is open and ready to write this down. Before writing patterns, let's look at our first function, re. Search. This function scans a string to check if a specific pattern exists inside it. In our code block here, we are looking for the word a Python inside a greeting string. If Python finds it, it returns a special match object. If it doesn't find it, it returns none. Let's run this simple block and see what happens in our terminal panel below. When we run the script, it prints found because the word matches exactly. But notice what happens if we change the pattern to a lowercase p. Regular expressions are completely case-sensitive by default. Searching for a lowercase Python will result in nothing being found. To fix this behavior without changing our pattern text, we can pass a special flag re-ignore a case. Let's add that to our code now. Now, let's learn how to guide our searches using anchors. The caret symbol, which looks like a small hat, forces Python to match a pattern only if it appears at the absolute beginning of a text string. On the other side, the $sign symbol forces a match only at the absolute end of a text string. These two symbols are highly essential when you want to validate full text structures, instead of just random pieces inside a paragraph. Let's look at this in practice. If our pattern is $admin, it means the text must start with admin and end with admin, meaning it must be exactly the word admin and nothing else. If a user inputs admin123, this pattern validation fails completely. This behavior is incredibly useful when building system logins, where exact username phrases or structural codes are strictly required. What if we want to check for groups of characters instead of single words? We use square brackets, called a character set. Writing 0 to 9 tells Python to look for any single digit between 0 and 9. Similarly, writing AZ matches any lowercase letter from A to Z. This allows us to build flexible rules for mixed data fields like serial numbers, codes, or custom user tags. Let's combine what we've learned to validate a simple employee ID code. The rule is it must contain one single uppercase letter, followed by a dash symbol, and then a single number digit. Our pattern looks like this: caret, bracket A to Z, dash, bracket 0 to 9, $. When we test the string key 5, it passes perfectly. If we test E5s without the dash, it fails. See how structured and simple data checking becomes? Up until now, our patterns only matched one single character at a time. What if a field contains multiple digits, like a phone number or a long PIN code? We use quantifiers. The plus sign means one or more characters. Curly braces with a number inside, like 4, mean exactly that many characters. Let's see how. Curly braces help us validate elements with fixed structural lengths. Let's write a quick script to validate a calendar year input. A standard year must have exactly 4 digits. Our pattern starts with a caret, then our character set 0 to 9, followed immediately by a quantifier of 4 inside curly braces, and ends with a $sign. If a user types a 3-digit number like 998 or a 5-digit number, our regex pattern rejects it instantly, keeping our database clean. Now we are ready for a real-world project, validating a standard phone number. Format. Let's create a rule where a phone number must look like this: 3 digits, a dash, 3 more digits, another dash, and finally 4 digits. Instead of writing long, complicated nested if-else statements in Python, let's see how cleanly we can outline this exact rule using a single line of regular expression. Look closely at the screen. We start with caret. Then 0 to 9, 3 for the first 3 numbers. Then a literal dash character. We repeat 0 to 9, 3 for the next block, another dash, and then 0 to 9, 4 for the final part, closing it with a $sign. Let's test 2 different inputs against this pattern rule to observe how Python handles them simultaneously in real time. Let's run the code. As expected, our first phone number string returns a successful match object and prints valid. The second string, which contains letters instead of numbers in the middle segment, fails our character set rule and prints invalid. With just one line of pattern logic, we've built a robust structural validator that protects our program from bad input data. Let's quickly review the core blocks we mastered today. Remember, the caret sets the start, while the dollar sets the absolute end. Square brackets let you pick ranges like digits or specific alphabet letters. Finally, curly braces act as your counters, telling Python exactly how many times a character type should appear consecutively. Combined together, they form a robust data validation shield. Here is your mini challenge for today: write a Python pattern that validates a zip code consisting of exactly 5 digits. Share your code solution in the comment section below. Don't forget to subscribe to the Edulexis channel and hit the notification bell so you never miss a day of this complete Python course. Keep practicing, keep coding, and I will see you all in day 50 tomorrow.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.